here's an alternative method to the Gaussian elimination method. Um, the first thing you should do is pick one of your equations and solve it for one of the variables. I picked the third one to solve for x just because the x is already positive and it already has a coefficient of 1, so I can just move everything over to the other side of the equation to solve for x. After I do that, I take that expression that I have, the y minus 3z plus 14, and I'm going to plug it into each of the other two equations where the x is. Once I do that, I need to make sure that I distribute properly and then simplify. That's going to leave me with two equations in the same two variables. Once I have two equations in the same two variables, I can use the elimination method, which is also called the addition method. I forget which way your book describes that one. And that's what I did here. Or you could solve one of the equations for one of the variables and substitute it in and use the substitution method. So I have the addition method here, or the elimination method, whichever your book calls that. So I just took the second equation and multiplied through by -3 so that I would get the coefficients of y to match but have opposite signs. That way when I add it together, I eliminate the y variable. So then I just have 38z equal to 228. I can divide both sides by 38 and solve for z. So I get 6 for z. Now I'm just going to plug that into one of the equations. I chose the second just because it was a little bit easier, and then solve for y. So I plugged in 6 for z into the second equation here, and you can see I just multiplied the 6 times the -17 and then added the 102 to both sides, and I got y equal to 5. Now I have z is 6, y is equal to 5. I just got to figure out what x is. For that, I plugged both of those into the bottom equation just because it was the simpler of the three. And I do go back to the original equations when I do that, just in case I've made a mistake somewhere along the way, rearranging things. But I plugged those in, and I got x is equal to 1. So now I have solutions for x, y, and z. And just in case I've made a miscalculation somewhere, I want to check all of these solutions. So I take all of these solutions, x is 1, y is 2, and z is 6, and I check it in all three of the equations because it has to work for all three of them. And when I do that, they all check. So I know that my solutions are correct. This method gives you steps that will work no matter what three equations that you have and three variables. Just pick one of them, solve it for one of the variables, plug that into the other two, and follow these steps, and you'll always be able to solve for all three of your variables.